Hi everyone, today we are going to learn how to calculate cell potential. So to start, we are going to write redox half reactions. All right, so here I see that zinc is being oxidized. It's going from 0 to +2. So I'm going to write the half reaction here. +2 electrons. And that means the copper is being reduced. Okay, so this is stuff we've done before. So the new thing here is that we are going to figure out the cell potential, which apparently is the sum of the half reaction potentials. So to do that, we're going to need a little half sheet. We're going to need a table to look at to pull these numbers from. So the table is our standard reduction potentials table here. And this is important that this is a reduction table. So we're going to find our equations on this table, and we're going to look at the numbers for these. Let's see here. Oops. All right, so here's copper. And let's start with copper. Since copper is being reduced, right, we can see here copper is being reduced. Then we're going to look at the number for reduction. So for copper, and this is specifically with 2 electrons, the number is 0.34. So I'm going to write that number down next to my equation here. 0.34 volts. And then for zinc, I want to do the same thing. Keep in mind that zinc is being oxidized here. So let's take a look at our table. And so here my table gives me negative 0.76. However, one thing to know is that, again, this zinc here is being reduced. So if I were to flip this around, right, then whenever I flip an equation around, I'm going to change this to positive. I'm going to flip the sign as well. So let's go back to our problem now. And again, instead of negative 0.76, I'm going to make that positive. And to calculate the cell potential, all we do is add up these two numbers. So we get 1.10 volts. What does a positive number tell us about this? It tells us that it is spontaneous. All right, so when you're looking at the table, anytime for oxidation, you do want to flip that equation, meaning we're going to flip this number. All right, let's do one more example so you get the hang of this. Here we're looking at lithium and zinc. So here lithium is going to be oxidized. I'm going to need an electron. Meanwhile, the zinc is being reduced in this case. Okay, so since it's a table of reduction, let's start with reduction. We already looked at this number. It was negative 0.76 volts. Again, for reduction, you don't need to change anything. Just use the number on the table. And then we'll refer back to the table for lithium here. We do want a balanced half reaction. So I'm going to multiply everything here by 2 so I can get those electrons to match up. Okay? But the number we get is not going to be affected by that. So I look at my table. Lithium's actually right at the very top here. But again, because lithium is being oxidized, I'm going to change that negative 3.05 to a positive 3.05. So instead of negative 3.05 volts, it is now positive. And if I do the math here, I believe it is 2.29 volts. Okay, and again, another positive number. This is spontaneous. And that's pretty much it. So even if you're balancing your equations with coefficients, that doesn't affect the voltage. Make sure for oxidation that you do flip that number, and you're really just adding two numbers together. I think you can do it. Let me know if you have any questions on cell potential. Be prepared to calculate these on your next test.